this question here is asking us to express each one of these forces, F1 and F2, into Cartesian form, Cartesian vector form, and then determine the resultant force, and also to find the magnitude and coordinate direction angles of the resultant force. So in order to do that, we look at this question in here and we look at the geometry. We can see that from F1 here, we've got F1, the force F1 is making transverse angles between X and Y axis. That means we will have one component in here which is shared between X and Y axis. This component in here is this one here in the middle, this component in the middle, and we are going to name it or assign to it F prime. So I'm going to call it F dash or F prime. So F prime is the component that is shared between X and Y axis for both angles that is transferred between F1 on the X axis and F1 on the Y axis. So the first step we have to do is to find F prime. When we look at this one here, F prime is making a right angle triangle with F1 itself. Therefore, if I take cos 35, which is adjacent over the hypotenuse here, I can find the F prime. So first thing the question asking us to do is number one here, Cartesian vector form for F1. So to do that, we need to find F prime. So F prime in this case will equal F1 cos 35 degrees. And we know that we got this one here, we got F1 cos 35 from this component in here. When we've taken cos 35, it's adjacent over hypotenuse, which is F prime divided by F1, and we solve for F prime, which resulted into F1 cos 35. Now to express F1 itself into Cartesian form, we'll say that F1 equal, it's a 250, the magnitude of it, it's a 250, multiplied by, the first thing you do, you put this cos 35 down in here. So cos 35 degrees. Now we're talking about the X component. The X component in this case here, which is this one, which is this component in this case, shared with the F prime. And this in this case is going to equal to sine 25. It's the opposite over the hypotenuse. The hypotenuse in this case, it's what we're having here, the F prime in there. So basically we are going to multiply by sine 25 degrees I. So this is the I component, plus when it comes to J, since the J it's on the Y axis, since J it's the Y axis and it's still shared with the F prime, therefore we are going to share again with the cosine here, cos 35 with it. So cos 35 degrees sine, cos 35 degrees. And now here coming to the Y component on the diagram in here, the Y component in this case, when we look at it, if we try to solve for this Y component in here, and then we can take cos 25 here, cos, this is making a right angle triangle with the F prime in this case. So cos 25, it's the adjacent, which is the Y component I'm looking for, over the hypotenuse, which is F prime. When you solve for it, it's going to put here cos, we're going to use cos 25. Already we've taken the F1 out, guys. So if you do it step by step, exactly will result exactly on the same thing. So remember that there are several ways to solve the same problem. So now coming to the last component, which is the Z component. Sorry, that's 25. This is here J. Then plus we're looking for the K component now, which is the Z axis. On the z-axis, looking at f prime, again sharing the z-axis, which is this one coming down in here, and it's a straightforward for the f1, and in this case here it's going to be the sine 35. So plus sine 35 degrees. Close your curly bracket, and of course that force is in Newton. But remember that this is going downwards, that means on the negative z-axis. Therefore, this is negative sine 35 degrees. Don't forget this. So now simply just plug in these values in your calculator, and once you put cos 35 sine 25, multiply it by 250, that should result into 86.6 I plus cos 35 times cos 25 times 250, and that should equal to 185.6 J. Of course, this is plus minus, it's negative minus. So sine 35 times 250, that should result into 143.4 K. And of course, this force here is expressed in Newton. Now, this is the Cartesian form for F1. So number 2 here, the Cartesian form for F2. F2 equal to 400 Newton, and it has got directions, coordinate direction angles. So straightforward, we will take the cosine for each one of those angles. So it doesn't have any transverse angles, it's got directional angles. Therefore, F2 will be straightforward. We will take the magnitude, which is 400, open curly bracket, multiply it. We've got on the x-axis, which is 120 degrees on the x-axis, directional angle. Therefore, it's a cos 120 degrees, plus on the y-axis is got here 45 degrees. Therefore, it's a cos 45 degrees on the y-axis, plus on the x-axis we've got 60 degrees between the force, as you can see in here, between the force and z-axis, 45 between the force itself and y-axis, 120 between the force and the x-axis. Doesn't have any transverse angles, and it's quite straightforward directional angles. Therefore, again, it's cos 60 degrees. Just plug these values into your calculator and you should get F2 equal to negative 200 I plus 282.8 J plus cos 60 times 400, it's 200 K, and of course it's Newton. Now we found F1 and F2. We know that FR, the resultant force, is equal to F1 plus F2, and this will equal to, open your curly brackets, F1, take the I component of each force in there, 86.6 minus 200 I, and that will result into negative 113 I. Do the same thing for the J components, 185.6 plus 282.8, and that will result into 368 J. Do the same thing for the K component, add both of them together, 200 minus 143, and that will result into 56.6 K. Of course, this is in Newton. To find the magnitude here, the magnitude for FR, for the resultant force, the magnitude for the resultant force is FR equal to the square root of all of these FR on the x direction square plus Fr on the y direction square plus Fr, the resultant force on the z direction, again square. Plug these values in, and that should equal to the square root of -113 square plus 368 square plus 56.6 all square. This will result into 485.30 Newton. Therefore, the Fr here, the magnitude of the Fr is 485.30 Newton. Now they asking us to the direction angles, to find these direction, the coordinate of the coordinate direction angles for the resultant force. So the direction angles, so we know that cos alpha, if we take cos alpha equal to adjacent over hypotenuse, for the x1 will be Fr on the x direction divided by the magnitude of the Fr. From here we can solve for alpha, which equal to the inverse of cosine for Fr on the x direction divided by Fr. Just plug into these values inside in there, and this one here, alpha, should equal to cosine the inverse of -113 divided by Fr, which is 485.3, and that will equal 103.5 degrees. We do the same for cos beta equal to Fr, the resultant force on the y direction, divided by the magnitude of the resultant force. From here we can solve for beta equal to the inverse of cosine of Fr y divided by the Fr, and in this case will equal the inverse of cosine times Fr on the y direction 368 divided by 485.3, and this will result into 15.1 degrees. Finally, cos gamma, and that is equal the resultant force on the z direction or z axis divided by the magnitude. From here we can solve for gamma equal to the inverse cosine inverse of the resultant force on the z direction divided by the magnitude force itself. From here gamma equal to the inverse of cosine. Just plug into these values here, which is 56.6 divided by 485.3, and that should result into 83.3 degrees. Guys, there are several ways to solve questions in statics. This is one of them, and that's the best one to show all of your answers, and so show your solution in that way. So the question is asking us to find 4 different things: the Cartesian vector form for F1 and Cartesian vector form for F2, then finding the magnitude for Fr, the resultant force, then the direction angle for the resultant force itself. We'll see you in the next video for more questions like these.